Hello everyone, I hope you had a great weekend and had a great time at homecoming if you went, and if you didn't, I hope you did something fun this weekend. But today we are talking about a definition in calculus that will come up very often on the AP test. That concept is differentiability, similar to continuity, same type of definition, where you got to make sure things kind of work out in order for something to kind of exist, which we'll talk about here in a little bit. But before we do that, let's kind of have a bit of a better visual so that way we understand what differentiability is. So in order to do that, we're going to look at a roller coaster. So we're looking at this roller coaster. Is this roller coaster safe to ride? So all of these graphs that we're going to see today, we're thinking about if we were physically on the graph riding this as a roller coaster, would it be a safe thing for us to ride? Okay, so here's our task. We've been asked to judge a design contest for the newest roller coaster at Cedar Point. However, a new roller coaster needs to be both fun and safe. So which roller coasters both meet those requirements? Okay, so take a second, pause, and think, what would you think makes a roller coaster fun to ride? Okay, I'm sure you all said a bunch of different things. Maybe you said you liked the steep decline, you like the speed, maybe you like the anticipation of going up the ramp. Those are all great answers. Next thing we want to ask ourselves is, what makes a roller coaster safe to ride? So kind of pause this video, think about that for a second. Okay, hopefully you paused this video and thought about something where you thought, okay, this is considered a safe roller coaster. Some things for sure to consider are the fact that we don't have any 90-degree turns, right? That would be pretty unsafe if I went straight over and straight down. I don't think that would work out very well for anyone. If there were any holes in the track, that would not be very good. So we don't want any holes on the track. And the last one that I thought about was flat track at the end. If it just ends. Okay. All right, so we are going to, for each roller coaster below, mark the point that it is the most thrilling or the most fun, and then determine if the roller coaster is safe to ride. Explain each choice. Obviously, maybe our answers are going to be different here, but let's kind of think the same idea in terms of fun. In terms of fun, we like thrilling, we like going fast, downhill specifically, or going maybe uphill kind of thing. So if I look at number 3 here, I would say my most thrilling points are going to be somewhere in the middle there and somewhere in the middle here, okay? This is thrilling because we're going down quickly at those 2 points. And it is safe. All the parts of this ride are safe. There are no 90-degree turns. It is going in a up and down path, just like most roller coasters. Okay, if I look at number 4, pause this video, think about what is the most thrilling point on this graph. Okay, maybe you thought this point here. If you think about, you're going up a track and then you instantly go straight down. That's pretty terrifying, quite honestly. At this point right here, it is thrilling, maybe. However, it is not safe at all to go straight up to a point and then instantly go down. And then letter 5, if we look at this graph, I am going straight down on the right, which is pretty thrilling. However, then I jump up to this point. So these points might be thrilling, but this is not safe. So maybe thrilling, but not safe. Okay, when I say things like safe and unsafe, that is using our new definition of differentiability. Okay, so let's just write underneath here. If I say safe, that is a differentiable function. If I say unsafe, that is a non-differentiable function. Okay, so for number 6 here, kind of using those 3 examples to help you, I would like you to pause this video and consider these 4 diagrams of roller coasters, which ones are unsafe to ride and why. So pause this video, take a minute to think about which one of these are safe, which of them are unsafe, and maybe why that is. Okay, hopefully you took a second to think about whether or not these roller coasters would be safe or unsafe, and hopefully we agree with all of the following answers. Okay, so these 2 ones on the left, these are both pretty safe roller coasters. However, the 2 on the right are quite unsafe. To go that quickly down and immediately back up, that point right there is not very safe. Same thing on this bottom one here. If I am going down and then I immediately somehow get transported or jump down to this point, that is not a very safe track. Okay, so there's some things that we need to consider when we're talking about differentiability. Now we'll put this on the next page here, but our definition of differentiability is that it has to satisfy 2 conditions. It has to satisfy the fact that f of x is continuous at a point, and it has to satisfy that the limit on the left and the limit on the right at a point are equal to each other. So basically that means the slopes on both sides are equal to each other. Okay? So if we look at both of the left pictures here of these safe diagrams, okay, of these roller coasters, these are all continuous and differentiable for all x equals a. For all of the points on these graphs, both of them are differentiable and continuous, because no matter what point I'm at, the slope as I approach from the left and the slope as I approach from the right is going to be the same, no matter what point I pick on this graph. No matter what point I pick on this graph, if my slope on the left and my slope on the right are equal to each other. Okay? Now, if I look at the right here, this first unsafe kind of picture, it looks like it's a V, so it's an absolute value graph. This is continuous, so our first condition is that it is continuous. So g of x is continuous. However, it is not differentiable. And the reason is because if I look at this point right here, if I look at the limit as it approaches a from the left and the limit as it approaches a from the right of my slopes, my slope on the left side is going to be a negative value, maybe -1, and my slope on the right is going to be a +1. So we need to state that condition. Or you can say that the limit on the left of our derivative is not equal to the limit on the right of our derivative. So this is a slightly different notation than our talking about continuity. It would look like this. The limit as x approaches a from the left of our derivative does not equal the limit as x approaches a from the right of our derivative. Okay, so this shows the fact that we don't have a differentiable function at x equals a. Okay, similarly for this k of x function, we can stop right away because k of x is not continuous. So automatically we can go ahead and say, therefore, those 3 dots mean therefore, k of x is not continuous, is not differentiable. specifically at x equals a. Because if I look at other points on this graph, like right here, the slope as I approach from the left and the right would actually be the same. However, there is a point that makes this function non-differentiable. Okay, and then an important thing to note here is that differentiability, if I know a function is differentiable, it implies continuity. That does not necessarily work the other way, okay? Differentiability implies continuity, but continuity does not imply differentiability. Okay, so let's go ahead and write these definitions down on the second page here. And then you guys are going to do problems just 1 through 5 to kind of check your understanding. And then after you've done that, or maybe you did this before, you guys just need to complete your flashcards over the derivatives topics that we've talked about so far. All right, so our important ideas, we need to put our definition of a differentiability function in here. So a differentiable function at x equals a. We're going to talk about non-differentiable functions on the right side there, so make sure you keep half of your box open. It must satisfy both conditions. Condition number 1, that f of x is continuous at x equals a. And the limit as x approaches a from the left of our derivative is equal to the limit as x approaches a from the right of our derivative. Key thing here, the derivative. Okay, or if you don't like notation, you can just say the slopes must match from both sides. Okay, that's a differentiable function. Now, if it is non-differentiable, one of two things happens. So at a point, maybe you have the function is not continuous. Or you have that your slopes from both sides do not match. For example, maybe you have like a curve down to a straight up line. Okay, our slopes are not going to be the same at that point that we can call A. And then just one more thing to note here is that continuity does not imply differentiability. Okay, so what I would like you to do is go ahead and try out problem 1 through 5. So 1 through 5 on this homework. Ignore number 6 and 7 because that's talking about using technology. I will explain that when I am back. So try those 5 problems out. We will talk about them next class. If you have questions, please let me know.